you may have seen that there is due to the Columbus section of ASQ. The other side will take you to the LinkedIn Columbus section. But you can't say you don't have the time to Columbus section. You have already marked the calendar. Mark the calendar for our fall conference. Our topic is what's in your toolbox. You will be looking for speakers at some point.
Now,
Now,
I already told someone,
you're,
and keynotes.
Bill, you're still arranging all the speakers, right?
Yeah,
Okay, Bill will be arranging all the speakers. If you aren't aware, I'm Becky. I am one of the conference co-chair. So if you're interested in volunteering to help with it or anything, my contact information is on the slide. I'm already written it down, right? Tonight's topic or tonight's presentation is the Statapult device, which you may have guessed from having Statapult devices. I'm gonna let Bill say all about it. Bill is going to be our presenter tonight, and he is the principal at Corporate Advantage Network. He is majorly involved in the ASQ, and he utilizes the Deming system of profound knowledge along with many technical quality tools to help companies with their I think most of you already know Bill, so I'm gonna keep it short.
yes. Thank you.
And
So I wanted to walk through some of the slides. You guys are pretty familiar with all this stuff, control charts, things like that. How many people have used the Statapult before? I know some of you guys probably have. You've seen it, have you used it? You've used it, John? Some of you guys have used it? What's that? Have you used it? Greenbelt training, yeah. So I have two of them over here. So we're gonna split you guys up into two groups. So you can work with them. So the Statapult itself has a lot of different functions for it. There's also another kind of Statapult that Mustafa has, is a little bit bigger. He couldn't make it tonight. So I got my two, because when I do like yell about or greenbelt training, I always incorporate this into that training because it's fun. I guess people engage and hands-on. So most of the time for the next hour or so, you're gonna be shooting balls. Just don't shoot them at each other. So calm down, kids.
the idea.
Now I gave you the idea. Don't shoot at each other. You'll knock your eye out. So that's what it looks like there. So the things we can do with it, I've got some graphs over here and some over here. So these two teams are going to be split up, and then you'll be graphing histograms, control charts on the flip charts I have on the side. So that's what we're going to be doing later. One of them is a baseline. You're going to just shoot it and just get what you get. And then you're going to redesign the process, create a better method. Then you're going to do it again. And hopefully you'll be able to hit the target a little closer this time, stay within control limits and things like that, or stay within the spec limits. So I got the spec limits listed on there, it's ±5 as what we're talking about. And when you look at a Statapult like this, you can do design experiments, you can do control charts, you can do histograms, you can do work instruments, all kinds of stuff you can do with it. So there's a lot of kind of fun things you can do with it as well. But really, I just want to get you familiar with using a Statapult, the X and a Y, you think about cause and effect diagram and things like that. The X are all the inputs. So when you look at these, and later you have a chance to look at it, but we can adjust all kinds of different things on here. We can adjust where this goes. We can adjust where this is at. It's got a number on here too, so you can pull it back all the way or a certain angle. So there's different things you can adjust on it. You can move it around. So we're going to talk through that. When you think about a cause and effect diagram, right? These are all the X's. This is all the inputs, and the output is hitting that target. So you think of this as our machine. This is what you're given to use, and you got to figure out how to use that machine to hit that target 100% of the time. See if you can do that. We have a target on there. It's ±5. So same kind of thing when you're redesigning it, right? The cause effect diagram, look at the machine and the methods and the people. So it's going to be a machine that you can't do anything about because this is a machine you're given, but there are some adjustments to it you can do. And that's typical with our work life, right? Because your leadership bought this machine, that's the machine you gotta use. So you'll get the output that you can get from that machine based on what they bought for you. So think about the equipment, the people, the methods, materials. Really the materials here is gonna be probably the ball. That's kind of your material. And this is gonna be your machine. You've got methods of how to do it, so you gotta figure that out as well. So we're also gonna do a histogram. So you're gonna be shooting it over here, and every time you hit, we need a couple inspectors down there, and it's gonna tell the scribe what number to hit. It's from 1 to 10, plus or minus 1 through 10. So someone's gonna be sitting on the end, read where it hits, and then plot it. So I'll show you how to do that. So the first time through, we're gonna just plot by about 30. I think I got like 25 on there. I think something like that, about 25 shots. Spread out everybody, 3 or 4 shots per person. And you're seeing a lot of this kind of thing. Here's our data, same thing we're talking about here. You're gonna get some data. You're gonna get the accuracy of the Statapult. If it just looks like that, it's kind of hard to figure out what's going on, right? So if you're doing it by hand, then you kind of see that curve starting to appear here. There's our normal curve. And this is about the midpoint right in here, 9.7, 9.9. So as we shoot it, we're going to capture that data and we're going to plot it. So that's what we're looking at. Again, this is a normal curve, but on these, it doesn't have a spec on it. I do have specs on here, but I don't have your control limits because we have to shoot it and calculate control limits based on the process of the machine. So we're going to graph the output of the machine, and that's going to be the voice of the process. What is this machine capable of doing? How capable is it to hit that target and stay within those limits? So it gives them the capability as well. So if I put spec limits on here, then you kind of see how much room you have between the process capability and what the spec limits are. So we're going to do a control chart. We're going to start just a run chart. So the bottom half of these sheets is going to be the control chart. The top part is the histogram. So you'll see both of them as we go through it. This is going to be data over time. You know, as you plot it, as you shoot it, you want to plot it, shoot it and plot it. We'll see what it looks like. You know, talk about the run chart all the time. You need about 25, 30 data points to see what's going on with the process. And that's why I want to get as many as possible. Like saying about 25 shots. That's about as much space I have on this chart here. You need about that many to see what's going on with the process, see what the control chart looks like. You know, it's like any process, going to be a lot of variation in here. If you can imagine that, what kind of variation you would have, but there's going to be a lot of variation in this machine here. I spent millions of dollars on these things, and this is what you're going to have to use. So don't whine about the machine. That's what we're given you. But every process has variation in it. So we want to understand what a variation is, how wide it is, what our control limits are, and things like that. And also there's going to be common special causes that might show up too. So after we plot this, we want to kind of see if there's something going on there. Is there a special cause or is it all common cause variation? If you think about the variation, common cause is management controllable. Like I said, I'm the manager and this is the machine I gave. This is what you have to use. So we're not going to get a new machine. We're not going to add anything to it. We're not going to tape it down. This is the machine we're going to use. So you have to kind of figure out how to use that machine to the best of your ability. Because that's what happens at our work, right? Because you have a machine, you can optimize it to a certain point. These are going to have a certain amount of accuracy to them, obviously. And so we're trying to figure out what's their capability of the machine. If I have a customer and I want some output for me, I need to know how accurate and what capability I have on my machine. So when I talk to my customer and say, well, I can give you this much range or this much or whatever, so you'll have problems later on. So the special causes, that's all going to be operator controllable. So depending on what the operator does, if he doesn't follow the method, doesn't hold it right, or we don't have a good method, that's all going to be based on the operator processes. Some of those might be special causes. So we'll play around with some of those as we go through it. So we're going to plot this out and we're going to get you know, what the process average is. We're going to kind of see what your average looks like. We're going to see what your range looks like and all that kind of stuff using this here. And we'll figure out what we want to do with it. I can take, well, probably, I'll take your data at some point and we can plot to what control limits are. If someone else has a computer, could do that for me, but we'll kind of see what it looks like, how much variation do you have, how wide is it, that kind of thing as we go on through. So I don't have the spec limits on here. If I did, hopefully spec limits are really wide. That would tell me I'm very capable. So my spec limits are much wider than the process width, means I'm capable of meeting those spec limits. So that's what you're going to find out. Are you even capable of meeting these spec limits of ±5 that me as your customer gave you? So I actually have a client right now who's going through that. They're trying to measure this part and the measurement system is pretty poor. And that's something else we're going to look at here too. You're going to have to determine how accurate is my measurement system. Measurement system is having 2 inspectors down there and identify what number it hit. So make sure you got calibrated eyeballs, make sure that's all squared away, because you got to identify where that ball hits. Believe me, it's not going to be easy. That's kind of hilarious, actually. If you go to an attribute agreement or maybe a gauge R&R in that, you'd have a lot of variation. So we'll go look at measurement error, we're going to look at operator error, we're going to look at settings, we're going to look at kind of work instructions, we'll look at the process. We're going to see what kind of range we have. We're going to see if we're capable. There's all kinds of cool stuff we can do with that. Just going to look at a control charts. Got to see when you first shoot it, and by seeing some special causes, common causes, seeing something that's going on that need to adjust. So there's a lot of rules. You guys are probably familiar with a lot of these, but special causes will be outside of control limits, but there might be some other stuff going on too. You're going to see all of a sudden, wow, everybody got maybe in the negative range, and then maybe it jumps back up, and now maybe it's all in a positive range. So you could have something like this, maybe 2 or 3 operators are shooting the ball, and they're all below target. So you got to figure out what happened there. Or you may find out, well, every time I shoot it, I keep going up and up. Okay, what's going on? What are we doing here for that? So you have some clues in there too. You got to try to figure out what's going on with my data. So I think I put them back there. I'm gonna give you a handout on this too. But what we're gonna do, we're not gonna do design experiments. Mustafa was going to do that, wasn't able to make it. We might do that maybe for a conference. So we can do some design experiments with the Statapult. I think the easiest thing to do for us is do control charts and histograms, because we can plot all that stuff. So that's what we're going to do. So first time through, we want to kind of split you guys up, probably these 3 tables here against those 2 tables over there. It's not necessarily a competition, although you could use this data to compare 2 suppliers. You guys could be 2 suppliers to me, and I want to see who has a better process. You could do that. Part of it is that I just want to get improvements. So we're going to do a baseline. I'm going to just shoot it, see where we're at. And if it's not within ±5, then we're going to spend some time. You guys are going to rearrange how you hold it, how you shoot it, all those kinds of things, figure out how can you get to ±5. So we'll give you some design time to design a new process. And then we'll say, well, design is up, shoot the engineer, production's got to take over and start following that process and see if they can hit that target every time. Okay. Maybe I'll, how about this? Instead of shooting engineer, we'll give them about $1,000, tell them to go down to the casino. So that's what we're going to do first. We're going to shoot it, get about 25 shots at it. We're going to plot that. So we'll do a histogram like I have up here. So all you're going to do is put an X. So if the first person who shot had -4, you put an X there. Just to pile it on top. Just like I had on another sheet. You just want to draw it, what the histogram looks like. Or you're hitting mostly zeros or mostly 10s or ±10. If it is over 10, count it as a 10. 10's the max, right? So ±10 is the max that you can have. So if you have all 10s, then you want to plot it either this side or that side. But that'll be the max. So if you miss it all together, try to figure out where it landed. So if you landed like way on the side of it, try to figure out where that landed on the chart. If it's not in close, then it's automatic 10. So that's the maximum we can do. And then at the same time, you plot one up here, you need to plot it down here on a control chart. So this is also a ±10. So you can see the control chart just flips 90 degrees from the histogram. That gives you 2 ways to look at it. The thing about the histogram, though, that's just one point in time. This is how I'm running today, histogram. Control chart gives you more data over time to see if you're shifting, because that could happen too. Once you decide where you want to put this, is it moving on you? Is it shifting or something's happening there that it's moving on you? So you have to kind of factor that in. So we're going to do this first. We do, and you'll create your histogram and run chart. And it's a control chart, but you won't really know what the control chart limits are until we put them in computer and figure that out. But for right now, you want to just graph it, see what it looks like. You've all seen a lot of different programs out there. You know, of course, you're going to be using our computers, plot data in there, or take data off the machine or PLCs and plot it, see what it looks like. So that's the same thing, it's the same principle. Out in the factory floors, you might have PLCs coming off of these, or probably down there, and it'll tell you where it landed, and you can plot that. That's where you get your SPC packages and all those kind of things like that. You could also monitor some things on your machine, you know, like temperature and humidity and speed, whatever is important. You can monitor that, and that's an input. For example, if I had like a motor on here, I could measure the speed on it or the temperature or the RPMs on it, and I can see if it's going bad on me, or I can figure out, is it staying within certain limits? So that's, we talked about the controlling the inputs to the process. So you got to think about, what are the inputs to the process here? How am I going to control those inputs so I get the output that I want? And those are your X's. X's are your inputs, Y is your output. The output is where it lands over there on that target. Okay. So what you're going to do, so I have one on both tables. So we're going to have to probably clear crap away for a little bit.
So where's the target? Right that.
Right there.
Right there?
Yep.
That cup.
That cup. So yes. You're going to shoot from this table to that table. And I have a tape set up. And- yeah, you can shoot that if you want. Go right there first. We don't use the tape yet. But right now we want to just start here. So we're going to start right where at the end where the tape is, and then you're going to shoot the target, and then you can graph it. Just see what we'll see what the baseline looks like.
Okay, we gotta move these.
Yeah, I think it's called Pong. Spear Pong. You could try that too.
This one I think is less critical for stuff to start off the table. Because it's going.
Yeah, you might want to move that coffee.
Yeah.
You want to take one.
Cleared the table.
All right. Dave, watch this down there. See what, everyone just has, depending on how many people you have, and you get 25 shots, so everybody do 2 or 3 shots. Just take it wherever you want to go, shoot it up there. And then hopefully it'll land. And that was a -10. That's a -10.
No, that looks like now. Oh, almost.
We might have to move that back a little bit.
You want to move the table?
Oh, you cannot move the table.
Change the process.
I vote the
before-
machine.
Overhaul the machine.
That's overreacted.
I want you guys to be able to do this. There you go.
I'll take that.
So I don't know where it landed.
I know, it's a little shallow.
Okay, so you want to rotate people being the inspector. I have 2 people down there. You got to agree on where it landed, and then you need someone who's the scribe who's going to record it. So first time through, just take it and shoot it. Just take it, shoot it, and then plot where it goes, and that's going to be your baseline. And then we'll spend some time re-engineering our process and how can I make it better to hit the target.
Try. Who's gonna be, inspector over this thing?
But you don't need this. You can use this cup later.
Oh,
But right now,
Just,
just figure out where it goes. Let's take that.
does it have teeth back there?
What's that?
It has teeth in there.
So this is just a guide. If it's over here, it's gonna be 1. Yeah, that one. Okay,
You gotta.
tape it down though. Let's take that down. Just tape the target down. Okay. Did I give you a ball over there? Bill, do you have the ball? Did they put the ball over here?
No.
How'd I give you a ball? We have both balls out, didn't we? Take them?
You got a bat.
We'll do yellow. We could use balls as another input, another variable, but we're going to just use the same ball. Alright. So figure how many people you got, probably 3 times a piece, and then record it up there. Yeah. Now who's your inspectors over there? So agree on where it landed. So plot -6, don't shoot yet till you plots it.
Okay, we,
Where's it? Don't shoot after you plots it, so you don't get behind. Yeah, you want to do both. I would do an X, so it might be easier. Do it like a big X on the histogram. And then connect the dots. You guys probably need about 3 people at a time to shoot. And we might have to,
Minus C.
we might have to move it up a little more.
Yeah, I think we gotta move it close.
'Cause you gotta at least be in a ballpark.
We gotta
Let's start over.
be close.
starting over.
Start again.
Starting over, guys.
Let's take that target down. So don't you-
Oh, the base one. Oh, yeah.
Yep, take both sides down.
So we're on the base one.
Right, yep.
Okay. And we made a goof, so we'll just ignore that.
Yeah, you want to put an X wherever they hit here and an X where they hit here.
Okay.
Connect these dots and
And
those,
what if it's the same thing, like it's, then you put. just-
and don't shoot yet till they plot it though. Wait till they plot it before you guys shoot.
Are you ready?
What was that again?
If he gets.
Ooh.
So now you move. it.
Yeah.
I think right here.
I would probably just, yeah, keep that off, but you can do that too, because it might hit. one, it might be going-
-2.
I would do it without the cup initially, do it without the cup, because you want to see where it lands. You can play with it around with that later. There you go. -4, you got that?
Okay.
Nope, you gotta go over here. We'll connect the dots. This is the dot more than anything. Connect those two
Okay, so like.
all the way. All the way down. Yeah,
Okay.
is you gonna,
Okay.
like I got up there.
Got it.
You guys are allowed to root them on though and help them out. You're allowed to help, give them some, get them some motivation. You can get them some motivation. Well, your motivation is tearing them down how bad they are. You know what I'm saying?
That's. Who hired that guy?
Just don't suck, okay, John? Just don't suck.
You got a scab come in there, that's how it works. Oh, no.
I love this. We got 4 inspectors and you're all different.
I'll go now.
Connect these as you go.
Make
to
it
the
rough.
how it looks like.
See how it goes. I think it needs an adjustment.
You guys see something going on before you shoot, Doug? You guys see something going on? Look where you're at right there. Everybody's done a low.
So.
We might have, I might have to make a management decision and get you in the ballpark a little bit better.
So.
I don't think you're quite in the ballpark. Don't think-
Plant two operators. Ready?
We'll go closer. There we go.
One more? We go 3. Yeah.
That was management controllable shift.
Okay, so we'll get.
I'll. Good job.
Okay.
Oh,
Pretty close.
what's the agreement? What's the agreement?
Oh.
So you kind of see there's kind of special cause stuff going on here, right? They're all low. A whole bunch of low at once.
Back of the way.
You guys are allowed to motivate her too if you want. You can motivate her. Cheer her on. Come on, Becky. Go, Becky. Go, Becky. Woo!
All right, one.
Apparently I have the magic touch.
She has got this.
That means you're an artist. You're not a science. It's not science. It's an artist. But you gotta train everybody else to do what you're doing.
Oh, that's perfect. Yeah.
Zero.
She's good. I think that's 4.
She's done. Her shift is over.
We're doing 4. Am I, is that?
Great. I'm a certified. I'm an industrial engineer. I just watch people work.
Jody's suspended.
Yeah, I want Jody, Ashley, I want you to do this perfect because I'm gonna record you doing a perfect shot. Okay? Perfect shot, right here. Okay, let's see. Let's
Ready?
do it.
That's pretty
Ooh,
close.
that's pretty good. What was it?
Yeah, that's good.
-2.
I'll take
Okay.
it.
That's gonna be in my work instruction, a video of how to shoot it.
Yeah. That's perfect.
Yeah, I need one more. Yeah, you guys have a lot of people, so maybe couple shots.
Find a hole.
Oh.
Yeah, right.
That it, Phil? Or there's one more. You can play one more. Yeah, room for maybe one more. Whoa, broke the machine. Okay, all right, so baseline's done. There's your baseline right there. It's kind of poor, not quite capable, it doesn't look like.
Well, actually, if you look at the, management can't do one after, it'll change.
Well, we weren't supposed to be any before and after. I made a management.
Okay, all right.
So take the next 10 minutes and redesign the process. You can play around shooting it. You got to try to get ±5. I want a very capable process right around the 0. That's nominal. 5 is my control limit or my spec limits. You want to be tighter than 5 to make sure I'm highly capable.
Plus or minus 5.
What's our capital investment?
Got it right there. You can adjust anything on there to try to get it as close as you can to a 7.
Yeah, yep,
Right.
-5.
Just like, you don't have to do them. I got.
How many more you got left to do? 2, 3 more? 3 more?
We got 2 more people to shoot.
Your chart looks like theirs. You guys cheating? You guys watching them do it?
Nope. One, Edith.
Okay. So I can change
We have 2 people who haven't shot.
All right.
Inequality, or you want to catch up?
Hey, guys, don't forget about the measurement system. You might have to improve that as well.
We're gonna get a
The
big.
measurement system's probably not very accurate. So how are you gonna make sure that is accurate? So that affects your results. Oh, my gosh. Who trained you?
Nobody.
Nobody. Why does that always happen? No one says they get trained.
You did.
Oh.
You like
did-
that?
did my- Management's fault. Oh. So take the next few minutes, try to redesign the process, how you're gonna hold it, how you're gonna adjust it, and also talk about your measurement system as well. So you got one, two more? And you guys shoot. And then you can redesign it.
25 things, right? How many do I have left?
You can probably stuff two more on it.
Okay.
Histogram, we can do a lot. Control chart, you run out of space. Woo! -2. Wait a minute, who trained Rita, by the way?
And it's left-handed.
-10.
Well,
Well, I guess it.
Yeah.
-7.
Okay,
Okay,
so spend a few minutes, 5-10 minutes, want to redesign the process by changing the settings here, your method that you use, and how you're gonna measure and make sure you're accurate measuring it as well. Because I've seen ±3 a measurement error on this. I don't know what you guys have seen. Or whoever, so everybody needs to rotate around measuring and shooting.
I would say, when you guys were telling me. Back here, I would count it all the way down. The further back. Right there.
Oh, yes, it's not. Oh, wait, let's see it better. Let's see it. Oh. Well, this, yeah, show the one, yeah. Either one. Now they can see the whole screen. Because before, my slides stuff, they just saw the level.
well, my hand was.
Live, they can.
Yep.
Even when it's recorded, that's not a change.
Yeah.
Hopefully.
we've got
We could maybe move it over to one of these guys.
Yeah. Seven.
I think we gotta move this up. Right now, we're at 120. What happens when we move it up to 110? I think you gotta get a little bit more on. All right, wanna try that? Give that a go.
Just remember, these are all theories you have, there's no right or wrong. Everyone has theories, you want to try them out and see who has the best process.
whatever.
You can have two
That went
people.
fast.
You can always have someone hold it, that's an option. You can have 5 people if you want. to hold it.
Now we could get a little left.
Yeah.
If you have rubbing on, go, it drags against the side, and that takes the energy. You gotta look down,
Gotta keep it separate.
you gotta look down the arm to make sure you got clearance on both sides, so it doesn't drag on either side.
Yes. You gotta come up with a method that's repeatable for all the operators.
Alright.
All the operators gotta have the same method.
Break time, break time.
Okay, so,
Yeah, yes, it's not
no, where'd you have it?
Oh,
Michael? I thought
Right
you had
up against the table, right in the front of the.
right in front of the table, okay? And that, I can do that. See this edge right here? Line that up on 170. This edge? And then watch that, you've got clearance on both sides here. You see, not like that, not like that. Okay?
No, I was trying to.
Doesn't dry.
I didn't touch it, that's the last shot, right?
So some of where it landed, not where it started.
Try it. See, look at it from here.
Nope, that was right here.
Oh, right. We're
But
putting
it
our
was
hand
very,
here.
but it was very gentle
Okay.
and all the way down.
You'll probably
Yep,
over here.
and I just let it gentle.
Yeah.
Ooh.
See, you're crooked.
So.
You actually don't break it up. Oh, that would break.
Can't move the table.
Can't move the table.
Table's part of the picture.
Yeah, we're ready.
But you can move that Statapult if you want.
So
There you go.
that,
Perfect, yeah.
right there?
That's.
Okay, give us tape again.
Remember, we don't have any constraints of how many operators, how many people you need to run it. You could have 5 people holding it if you want. It just costs us more money, but hey,
We don't want that. After all, we are.
we can't do that.
Oh.
Not allowed to tape it down. It's the rules.
Where? Show me the rules.
Right here is my rules. These are my rules.
Where's my screw gun? I'm gonna screw it to the table.
You're not allowed to tape it down. You guys in production now? Is that what you're doing? You're in production? All right.
Yes,
You gave the engineer vacation?
because we've got to get somehow. Let you know. it's just-
All right. Now can that be repeatable? 10 people.
Whoever's taken whoever's.
John's gonna be your calibrated inspector. Is that what it is? You're- it's- You have the final call?
Right? You have the video. Have the video, then you.
Good.
You get it very
It'll take about 3 more minutes because they've started production already. So figure out your process the next about 3 minutes. And then run production. Time to give engineering vacation.
We bump this back up and
We can try bumping that back up if you want.
okay. I don't know, it's pretty close.
We're all bringing it all the way to the table, right?
Yep.
Bump.
You guys are pretty intense on this side here. They're focused.
They're very focused.
Ooh.
Oh, that's a little too much.
Yeah.
Think we're better off.
Oh, wait a minute, somebody needs some motivation here.
We'll get
We need to motivate somebody.
Doug. Doug, drink less tea. Nice to.
You're gonna be at a performance improvement plan here, Doug, if you don't hurry up.
I know. With a bit. Want a bit here.
You're wildly out of control.
Ooh.
Oh.
That's gotta help. Hey, wait a minute. Did I tell you guys I don't want any out of spec product? Did I tell you guys
Sure.
that? I don't want any out of spec product here.
Just sweep it on the right.
Do what most companies do. Don't record it. You guys ready for production?
Somebody's got them.
We need a scribe over there.
Oh, right.
Yeah.
Right, let's see where you're at.
Ooh.
Not too bad.
Uh-oh.
What was it?
I think
Yeah.
of course, now we moved the whole card now.
I was mailing.
Everybody has a theory.
We have to have everybody shoot.
Yes.
Oh, we gotta have everybody. do it.
Everybody's got to shoot. I don't want one person who's really good at this, and know everybody else is terrible.
Oh, darn.
I got people on my vacation, I got different shifts, I got all kinds of people that rotate through here.
Yeah, but you know, we only have Charlie run that one machine.
Not anymore. Charlie's on vacation for 3 months.
Charlie did not go on. That's the only guy on the planet that can't go on.
You mean when somebody goes to the hospital, they can't shut down the PC? What if we hold it back?
Oh, yeah, oh, yeah. No, that's not like an uncommon thing. People say so.
We'll take one more minute, guys, to it's 10 after.
Then it's her, she's in the hospital for the next 2 months. But then we can run the GC. What do you mean you can't run the GC? Well, Terry's the only one who knows how to fix this.
Yeah,
Okay, that's a problem.
yeah. Yeah.
Well, what are we gonna do? I'm like, take
All
it.
right, where are we at?
-7.
-7, okay.
All right, we'll come up with a method so everybody can do it and train everybody. So we gotta get into production now. We gotta make some money. So we'll go into production. Who's training?
Do that one thing.
I think we're, yeah.
That's back where it was.
Every return.
We returned it to the.
Yeah. Now we gotta go all the way down to the table. On the side of that.
Yeah.
All right.
All right, so you
Yeah,
got,
where are we
you
putting
got a
our
method?
hands? Where are we putting our hand? The front, so we're putting it right here behind us. Okay,
All right,
I think
go
we're
in
good.
production.
and we gotta hold it the whole time, because we wanna make sure even when.
If you guys want some consulting help, those guys over there be willing to consult with you.
Oh, we can't afford that.
Hey, maybe we should stop for a second. What's going on over there, guys? Where's our consistency at? We got some special causes going on here, or what's happening?
I think they were measurement. It's
Measurement error?
It's always,
Who's that? Who's the first 2 people? I want them back.
I know this one, well, you know, this one was.
I want names. I want names of who those people are and are out of spec.
You know.
At the bottom?
this flat.
Okay.
This flat, it's right there. It's gotta be on 70. Make sure you got clearance side to side.
Okay.
2 fingers, let go simultaneously.
Okay. Oh, here we go, guys.
Oh.
No, let's six. We're gonna be real.
Oh, they're all 10s, except 1 9. And I did odd for you guys. See that.
So, see this 4 dots in the middle?
Was that you?
That was me.
So what happened?
They changed the settings.
They did that? They did that?
The settings were changed. Yeah, well, what does that mean? Settings were changed. Okay,
Who's next?
Jody, you get to go next.
Okay, I get something.
Your second shift is up. Did they train you? By the way, who is your trainer? Dave, you're the trainer?
I guess.
-7.
Wait a minute, hey, did I tell you guys the spec is ±5? I'm trying to get some good product out here. Did I tell you guys that?
Yeah, you did.
±5?
Yeah, you did.
Okay, want to make sure.
You did.
Want to make sure we're on the same page.
You did, but you also said we needed products. So we did it. -7. Yeah, gotcha.
This is not Boeing, you know, we record actual results here and we do inspection.
I say, if you got, ship it out.
Yes.
Get these off of the website.
Yeah, I got it up there.
All right, I got it on. Catapult. Cause I wanna do this in the class.
Isn't it fun?
Yeah, but
Main things to do with it.
right, but you think about 18 to 22-year-olds these days, right, and trying to,
They gotta do stuff.
they have to do something.
You can get 3 of these.
What's that?
So you get the 3 of them, so you only have like 5 or 6 people per.
It's like, I would get probably 4, cause I have a
Yes,
class of
yes.
25.
Yeah, $260.
I took pictures, I was
There's all kinds of stuff.
Right, exactly, I done it when I was a Rolls Royce. They did this.
Right.
But,
You're not burning Rolls Royce? Oh, yeah, I realized that with them over the years. Oh. So are you guys capable of meeting my spec limits? I think your CPK is about 0.1 or maybe -2. Worse. You can maybe, if you want to keep improving that, how can we make it better?
I think we should find a way to get it so you don't have to do the work.
I'll let you do the tape it to the ground, whatever you want to do, see if you can make it even better. See if you can get it in that cup. Can you get it in that cup?
Yeah. But take it all the way down and.
Ooh.
From -10. And what were these things again when we changed it? 110, and then what was this one on?
Originally, this one was here, we moved it down one. And this one was originally here and we moved it up.
So I didn't know, I didn't remember what this one was.
That was originally at the highest spot.
How many do we have so far? Oh, wow, we need a lot. We got about 15 minutes, so we need to hurry up production here. I think I'm gonna get a new plant manager and a couple new supervisors here pretty darn soon.
Let's give that.
There's a reason I don't work in the plant.
What's that?
There's a reason I don't work in the plant. Plus 10.
I think you were the one getting distance before. I don't think we should have adjusted.
What Demi calls this is tampering. You guys have been tampering with this thing for the entire duration of production. That's where I get so much variation. Because we don't have a set process. We're tampering.
I'm not sure how you're getting the distance.
We just went the other way.
Yeah.
Went the other way. Man,
Plus 10
Whew.
for the third one.
No, you don't need to get, you don't actually don't need the highest pay.
you don't have to. Ooh,
Wow, you are
Plus 10 for
consistent.
the fourth one.
I'd rather you be consistent than
Already went.
inconsistent. Because if you're consistent, we can adjust it easier.
Of course.
If you're inconsistent, that's called special causes. You're all over the place.
Yeah.
What's that?
Got one off there.
No, we can't.
Yeah, this is way too strong.
That's way too strong. Move it down a bit.
Well, that's what we're doing to begin.
Well, we were saying it was too weak there. But there must be a difference in how we're doing it. I know when she was releasing it from here.
The other piece of
You can hold
it was
it.
not.
You can do the top, that this way, this
But I
way.
think if you release it from here, you're getting a lot more snap. You're getting a lot more snap. And that's what we're seeing. I think release it from here. Release it from here. Let's see where we're at. Problem is, we don't really get really good.
What happened here? Did you get your drill out and hammers? What are you doing?
rubber band broke.
I actually noticed there was a little cut in there when you guys were starting to shoot.
How long is this? How old is this machine?
Huh?
Need some capital.
Yeah, I probably need to buy some new ones. I think Ashland should buy me a couple of them. Now you changed that variable
I
total.
know, we did it again.
This is the
ready?
person you call maintenance. He comes out and just rewires everything,
Let's.
puts all new equipment in.
Maintenance.
Oh! I
Oh,
kinda like that.
made it power.
That's a good 3-point shot right there. Let's get a few more shots, then we'll wrap up.
Okay, who's next?
You wanna go?
I already went. You're
I think it's all the release.
That's your theory.
Well, that was just me. Now, I guess we will see, okay.
So we just call these theories. It's not anybody's right or wrong. You have a theory of what you think will work, so we need to try it out and see if it does. We'll learn from it. We're
Right.
just trying to learn. Oh.
-5.
Sorry.
It's all right. Oh,
We
I let it hit my hand.
special
That
cause.
was a wink.
-10.
That was a wink. That was an operator error. Re-instructed the operator.
Well, did everybody shoot there?
It's fine.
You shoot?
I think Hugo needs to shoot.
And Hugo, shoot a couple, then we'll wrap up. We'll talk about how we're at. These guys are still in production over here.
Okay.
I mean, we wanted stuff, Bill. You wanted it today, right? Not
Yeah, I want it
week.
today.
You didn't want it.
That's right. We're trying to make some money here.
You want quality parts or you want them like today?
Yeah, give me quality parts.
Okay, today or next week?
A customer wanted them yesterday.
What do you want?
You want a good one?
Ready?
How about marginal ones?
We'll be able to get it.
We had 2 -10s in a row just now.
At least be consistent.
We're gonna blame RSU's on COVID.
-10.
Blame what?
We're gonna blame RSU's on COVID.
Yes. All right, is that one more?
Ready?
Okay.
Now,
All right, you guys can have a seat. Appreciate it. Bill's gonna get this down. One more shot.
sorry about.
We'll do one more shot.
One more shot.
One more shot.
Start with beer pong
Okay. All right. All right. So what is kind of fun? It's kind of neat exercise to do, right? With your group and got maybe from school or whatever. There's also so many things you can do. You got measurement system analysis you can do with it, right? You got design of experiments, you got work instructions, you got control charts, you got histograms, you got capability you're gonna figure out. So right now, I just want to know, was either process capable of meeting my spec limits?
No.
Sure doesn't look like it, does it? So what's going on here?
A lot of variation in operators.
Yeah, I gotta fire all you guys. I'm getting a whole new crew. I'm gonna pull an Elon Musk here, fire the whole department. I'm gonna get a whole new set of people.
What's our severance?
Yeah,
But you can never put it back on the person,
it's not the person, right?
okay?
Does everybody agree?
Okay.
Maybe some of you were a little worse than others, but this is what we have to deal with, right? We have people off the street. We gotta have a process. Anybody who comes in there and does it can do it and get me within ±5. So that's our challenge, isn't it? When we're at our businesses, how can we have a process that's robust enough, is not person dependent, And as I rotate people through and get the same output every time.
Right.
Not easy to do, is it?
But you have equipment there too, because it moves, so if you bolted it down, you stabilize that.
That would help.
Yep.
See, that's some of the things you could do to the equipment. Right now, that's the equipment we have. That's all I can afford. So we gotta make it work. There might be some things we could do, right? Because there's a lot of wobbly and some stuff, some variation. There's a lot of variation in this thing, isn't there? But you can get it there. Maybe spend more time. You guys could probably hit it there pretty consistently. I have faith you can do it because I've seen people do it. You can, because you could tape it down. Because that is one variable, isn't it? Of how you're holding this thing down. It's moving all over the place. You got the variation here. You got the variation how you hold it. You hold it like this, or you hold it like this, or what setting do you put it on? And then going back to some of the Deming teachings, these are just a bunch of theories that people have when they're together in a group. Sometimes we don't voice our ideas. What I say is get everybody's theories and try them out and learn from it. It's all about learning and gaining that knowledge. So if someone thinks, well, I think we got to put it on 130. That's my theory, that'll hit it. So let's try it out and see how it does. And if it doesn't work, do something different. So that's where that PDSA, that thought problem solving process comes into play. So how accurate do you think we were in the measurement system? Plus or minus what? How many discrepancies? We have 3 people inspect it. John, 3 people? How many different answers did you get? 3? Most of the time. So the first thing we got to do, right, is to have a measurement system analysis, make sure measurement system is accurate before we do anything to the machine. You agree with that? Because we don't know exactly where we are. Every time I adjust something from here, I don't know where I'm at. We got to focus on the measurement system first. So maybe that's going to be an electronic scoreboard. It's going to be a sand trap. You can do those long jumping. If I do long jumps, like jump in sand, I can see where they landed. So we have to figure out a measurement system of what we're going to measure, make sure that's accurate. Because this problem, plus it's funny, I see people say 2 and some say 8. You've probably seen that. Have you seen that there and the variation and all that? So that's got to be fixed. And then take the variation out of this. So when we talked about the inputs, these are all the inputs. This is X, the cause and effect diagram. The output trying to get is that target. That's the Y. This is the X. All these things are variables. We got to try to adjust and set. And once we figure it out, then we can train somebody, put it on 150, tape it down like that, put this in this hole, hold it like this, do videos, do training, and then hopefully get consistent product out every time. So training is also very important. Take videos, instructions, pictures, train people. We don't want artists. In business, you can't have artists. You can't have somebody who's real good at it and 50 people who aren't. We have such high turnover and shifts, people go on vacation. If I have a process that's people dependent, I'm in trouble. We probably have a lot of processes like that, don't we? That are people dependent. We got to get it away from the people. Kind of thing like that. That's kind of fun. Like I said, other Doug said you can probably buy some of those. But the $260, I've had these for a long time, you can probably tell. Again, now I get new rubber bands for that one because they broke it. I did notice it had a little tear on the rubber band, so I'm not going to blame you. So it's going to go any minute now, which is part of the PM process, which is a factor in our equipment as well. That's another factor, right? How I do my preventive maintenance. So all those things are factors into this, right? So there's a lot of stuff you can do to it. Like I said, does a lot of design experiments with this. So I don't have all these factors. Think about the different factors. This is a factor. What number do you put it on? This is a factor. What number you put this on? So you can do some experiments. Okay, I'm going to shoot it in this hole, in this measurement, and this way. Shoot it several times. Then you change it, and you can do an actual design of experiments and find out what's the best process I need to hit that target. And you go, okay, my DOE now tells me I need to be here, I need that be here, and that there. I want to hit it every time.
So you got a rubber band's a variable too.
Rubber band for sure, because there's broken stretching.
Leave the fatigue over time.
Exactly. And that's where the preventive maintenance comes into play. And also you want to look at your machine and see, does it wear over time? Think about drill bits and machines that cut. The bits are going to be wearing, bearings are wearing, things are wearing over time that you got to figure out, do we need a more robust rubber band? But need to change the design altogether, maybe use something else. I don't know. So, like I said, that's where you can get it if you guys are interested in having that. It's a lot of fun. I use that all the time. You guys agree that's kind of a good learning tool? Yeah.
How long do you spend with somebody on this, in terms of?
About the same amount of time I spent with you guys today too. If I'm doing like a yellow belt class all day, this is usually at the end. Kind of wraps everything up. It's about an hour-ish. So, because you're hitting all the tools, right? And it helps wrap it up. So I use it, especially on yellow belts, one of the last things I do. I also do some other simulations I was gonna do for the fall conference on making goalposts, making lean, so I have a lean simulation, then I have this is a Six Sigma simulation. Right, this is about data, data and measurement and that kind of stuff. But the other simulation I do is the lean one. So there's kind of two ways to look at it. Sound good? Cool. Thanks, guys. You had a lot of fun. It's pretty good. Appreciate it. So, I think, did you mention the zoo yet?
I did not
Okay.
mention the zoo. I realized when I said.
When will they send out for the zoo, like this week or something like that? For the zoo? He's just there and glare. Blank face. So we're gonna have the zoo tour next month though, so look out for that email. First 25 people. We did it several years ago. What's that?
It's a different time than our normal meetings are.
Yeah. I forget what time it is, a little bit earlier. Yeah. So it's after hours at the zoo. They're gonna show us their sustainability. Do you want some elephant dung? They can tell you where you can get it. So it's kind of fun. See the zoo. They'll show us around a little bit behind the scenes. So if you want to go there. But it's open to everybody, but we only have 25 spaces to do that. And don't forget the fall conference. I'm looking for speakers and keynotes too. All right, guys, appreciate it. Thank you very much. Hope it's not raining out there. See you next time.
I gave you a big old chair.